Hello, 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 hello. I don't know if you guys can hear me or anything. Just check if audio is coming. How do I share link first? Let me share it to Twitter then. I'll. Is it 7 yet? No, it isn't. Did I post? Give me like 2 minutes. I'll start. I think it's audible and visible also. No? Or did I not start the. Yeah, it's audible. It's audible. Give me 1 minute. Yeah, I'll start. So, what is linked list? Okay. So, why did we even create linked list? The problem with arrays is basically when you're creating an array, right? So, this has a fixed space. This has a fixed space. So, if let's say this can contain what? 5 elements. So if I want to add a sixth element, I can't add it anymore in the array. Linked list, what we try to solve is that we want to create kind of a memory that, wait a second. Yeah, give me 1 minute. Something important came up. Yeah, yeah. Sorry. So I'll continue. So what linked list try to do is basically let's say this is not how a linked list looks. So let's say a linked list has this much space occupied. So what it does is that it can extend the space as much as we want. Like we can add another one also. So how does it achieve that? It does not create contiguous memory like what you see, the 5 elements. So this thing is wrong basically. I just tried to explain you, that's why I wrote it. So what linked list is made out of is basically a node. This is called a node. So what is a node made out of? The node has a data and a link. Okay. What does it mean? So this thing basically means that linked list will have these small nodes. Like in arrays, we had what? Arrays we had elements like 1, 2, 3, 4, 5, 6. Here we will make something called a data and a link node, which are basically structures. Okay, structures or objects. If you're studying any other language, I'll use structures because I'll do C. So what happens is that if this is a linked list, right? If this is a node, let's say we have two more nodes like this. Okay. So let's say if I'm storing data 1, data 2, data 3. So what linked list does is basically this point is linked to this node and this is linked to this node. That means what? For example, let's say this has a value of, this has an address of 100, this has an address of 200 and this has an address of 300. So it's not uniform in this manner, but just for the sake of the program. And we are storing 1, 2, 3. So what will be our scenario? Let's say So I'll just copy paste. So our data, first data will be 1, second data will be 2, third data will be 3. Link will contain the address of the next node. That means it will contain 200. This will contain what? 300. And what is this pointer pointing to? There is nothing after this. So this will point to null. Now you might ask, why? Where are we storing this 100? Like, how will we access the linked list? So what we actually do is basically store this in a separate pointer called the root or the start pointer, whatever you want to do. So root will be, what's the value of root here then? 100. So if we have the root value, then we have the this node, and from this node we can go from this node to this node. So if you see, this is not a contiguous type of memory. You don't have fixed space. So let's say if I want to add another element here, let's say 4 at 400. This will point, this will have 400, and now this will point here. So see, you can actually store as long as you want. And you can delete also if you want. If you want to delete 3, we can delete 3. We will make this point to 400. Then this will go and point here. You can do insertion, deletion. That is the main thing. Okay. If you have understood what this is, what basically a linked list does. Now, how do we define this? I'll just write the short code. I'll not write much code today. So struct node star. What will be the first thing? One integer, that is our data. And what is our link? Link stores the address of the node. So it will just be struct node star link. This will be our basically node structure. So this is how we define a linked list. How can we traverse it? Very simple. We will move from this. So we will just what do you call it? Yeah. So once we have root, so this is my root. So root dot link will be my next, and next. We can traverse it like this. So if there's a linked list, right? So you can just do this, na. So let's say there is a temp, and I do with that root, and then while temp not equal to null, print temp value and temp equal to temp dot next. What does it do? This is a basic traversal code. How does it work? See, my first, why am I not taking root? Otherwise, if I did root dot next, you will go and you lose the whole linked list. I don't want to lose the whole linked list. So I assign another value temp. So let's say this is now, there's another value called temp, and this is also assigned to this. Okay. Now, first what we'll do, till temp is not equal to null, we will print temp dot value. We printed temp dot value. So what will be our output? 1. Then it will go what? Temp equal to temp dot next. So wait, I'll change the colors so that you will understand. So once it has printed to this, it will now go temp is equal to temp dot next. Now temp will be this. Understand? After this, is temp null? No. Then it will print the value. So it will be 2 now, and then 3, and sorry, and 4. Sorry, I deleted 4. No, 3. No. So now the temp is here. Now what is temp equal to temp dot next? What is my temp dot next? Null. That means what? It will not print anything. So I got 1, 2, 4 like this. समझ नहीं आया? Arrays के जो index रहते हैं linked list में नोड होते हैं without an appropriate address. हाँ. So the basic idea of this is that in array what happens? No. Let's say this is 1, 2, 3, 4 in array, right? So what happens in array is that key 1 has 100. Let's say 1 has the address. Here, I'll change the color. 100. Okay, 1 has the address 100. So in arrays, it is contiguous memory. Means एक के बाद एक रहेगा. Next one will be the size of integers. 104, 108, 1011 like this in an array. But in linked list, the nodes, let's say this is a node and this is a node. I made three nodes next to next. Okay, they are not contiguous. So what happens if it is not contiguous? Let's say this will be linked. Wait, it's too thick, bro. Yeah, this will be linked to this, and it might be this linked to this. They are not next to next. So what happens? This is my first. This is my third. This is my second. If you understand, no, no, I don't think it's a blank screen because I have a second device where I'm watching this. Yeah, you cannot change the size of an array. Once you have made it, that's the size. But in linked list, you can, it does not have a size per se. You can increase, decrease to your choice. So this is the basic idea of a linked list, how to traverse it. If you have understood, I'll move on. How to insert and delete. Okay. I'll just delete this. Okay. That would be better. I made a linked list. Actually, good looking linked list. I'll not delete. Yeah. So this, I'll make 1, 2, 3, 4. Wait. Give me 1 second. Yeah. This is what static and dynamic memory. No, but arrays you can do dynamic memory allocation. It's not like in arrays you cannot do dynamic memory allocation. You can do, but here it is array. Even after dynamic memory allocation, it's static. Not static, like it's a fixed size. Okay, so let's say this is our thing. So first we will do insertion. Okay, how do we do insertion? To insert at begin. So let's say our node. Okay, we let's define a node. Okay, fuck the addresses, don't need the addresses. Yeah, this is the root. Okay, so let's say I want to insert 7. We have to insert 7 at the first position. So what should we do? It's very intuitive. You should know this. So if this is here 7, I want it to be the first node. So logically, what should be the first thing to do? I will point this node to the first node. Okay. Yeah. Then this will become my root node, right? So now I will make root point to this. That's it. This is how to insert at begin. So insert at begin. Wait, why did, yeah. Insert at begin. How does insert at begin end? Let's say the new node, right? New node dot link is equal to my root, whatever my root was, and root is now equal to the new node. So this is what insert at begin does. Why did the whole thing change color? Okay, so this is insert at begin. Okay, now let's try to do insert at end. Okay, yeah, insert at begin. I'll write it here. Now insert at end. How do we do insert at end? It's very simple. Just take, let's say I'm taking this here, right? You just have to point this to this, right? And it's done. Nothing else. This is that. So this is what. So first we have to traverse to the end. So first we'll make, let's say, insert at end, right? Now insert at end. So what we'll do first, we'll traverse. I'm not writing the traverse code against traverse till end. Then what we'll do, temp dot next is equal to new node. This is insert at end, right? Now how do I insert at middle? Okay, let's say between 2 and 3. First you have to reach till 2. So let's say we have to traverse till 2. Now what we have to do, there is one thing that might go bad is that you might do this. We'll first attach this and then we will attach this. Can you tell what's the problem with this? The problem is that whenever you attach the first one, this one gets deleted and this part of the linked list is lost. I don't want that. So what I will do is first attach this, then I will attach this. So this will become 1 and this will become 2. So this is my step. The inserted mid will become what? Traverse till 2, then temp dot next. No, that is the earlier one. So whatever my new node is, so new node dot next is equal to temp dot next, and this is my temp. Okay, this is my temp currently. This is the condition I am doing. So temp dot next, and when then what happens? First connection is done. Now temp dot next is equal to new node. Try to understand all of this very counterintuitively. What I have seen with most people, 90% of the people can't imagine this whole thing. That's why people can't like solve this. Like, I am not seeing any notes or writing this. Okay, the only way I am doing is that I can imagine this. That's why I'm doing it. So when you're doing linked list, please try to imagine. Okay, otherwise it's useless. You should try to imagine as much as you want. Okay, this is my insertion. Let's try to do deletion now. Let's say we want to delete the first node. So what do we have to do? It's very simple. We will just make root point to this. Then this connection gets detached, right? So my delete at end, delete at beginning is nothing but what? My root equal to root dot next. Simple, nothing else. Very simple. If I want to delete the last element, what do I have to do? I have to traverse till 3, right? How can I traverse till 3? That's one big question. Here I have to use the concept of double stuff. Like, I'll keep two things. One will be previous and one current. So here we have to learn how to carry 2 pointers. So I'll teach you this. So while traversing, what we'll do, while let's say temp, I'm making it current dot next not equal to null, as in the last it will go, and we will make previous equal to current and current equal to current dot next. So what will happen? The previous pointer will point to the earlier one, and the current pointer will current pointer will always be like the normal traversal. Edge case root node changes. I don't know what you mean. Can you explain? Like, write it better, then I can explain. So now deleted end will become what? I will just do what? Previous dot next is equal to null. So what will that bring? This will delete this thing connection. So that gets lost, current gets lost. That's it. I'm not explaining how to free. You should free to save memory. Otherwise, there might be some garbage values. Please free the values which you're deleting after it. I'm not explaining it that much. Now, if I want to delete, let's say 2. So what, let's say I want to delete 3. So what I'll do is bring 3 to be the current and the earlier one to be previous. That's it. Now, what you will do, I have to point this to this. Like, my whole idea is to point this to this. Right. So one easy thing we can do, delete at mid. Okay, logically think, what can we do? Previous dot next. No, previous dot next is equal to current dot next. So what will happen? This gets connected to this. So of course this connection disappears. So this current is still there. So I would tell you to free the current. So this will disappear. So if you free the current, this will disappear. That's it. I'm not writing the freeze at the end. Just free the everything and you'll be fine. So this is insertion, deletion, done. I hope everybody understood, whoever is there. So I'll just do circular and double after this. Give me like 1 minute break. Yeah, let's continue. I was just drinking some water because yeah, speaking for these long hours is not possible for me. Okay, so let's copy paste this and add it. Okay, let's consider the case of circular linked list. In circular linked list, what happens is that we don't the whatever we studied right now is called single linked list. Okay, the circular linked list, the end pointer is not null. The end pointer always points to the root. This is the scenario. So this will contain the root. As simple as that. This is how a circular pointer works. Okay, or you can just like make it look like this. Yeah, this looks better, right? So this is how circular linked list look like. Okay, so if you wanted to see, I will not go into that much code detail anymore because yeah, it's counterintuitive. You can understand using the earlier logic. So I'll just explain how this shit works. Okay, so let's say I'll add one. Yeah, the 7. Okay, let's say I want to add this 7. How can we add this 7? We will just do this. We will connect this end wala to this, to the null. Okay, so this will contain now 7 address. Let's say 700. Okay, and then I'll point this null to the root. So this null now becomes root. I hope you understand. See, it's circular linked list. So now we inserted it at the beginning or we inserted it at the end. It's the same logic. Because since it is circular, there is no beginning or end. So whatever operation I did right now is inserting at beginning and inserting at end. Because there is no end or beginning. That's the logic. And inserting at middle, let's say if I want to insert it here, right? It's the same as the normal case. So I'm not explaining it. So now let's discuss how to do insertion at um sorry, deletion at beginning first. Okay, if we delete at beginning, okay, so this is my end. Let's say this is my temp currently. I'll delete the previous current. This is my temp, and wait a second. I think I should put a previous and cur in this. Pref will be this, and cur will be the thing we are trying to delete. So what we will do is that we will do this. Let's do this. Pref dot next is equal to cut dot next, just like last time. So this will lead to this pointing here, right? And we'll change root is equal to cur dot next. So now the root will point to this, and then we'll free cur. So this gets deleted. So this is how we deleted an element at the end, at the beginning. Sorry, but now let's try to delete it at the end. Okay, let's say pref what was the code? I forgot. Yeah, root is equal to cur dot. This was the code. I'm just not deleting just so that you guys can see it later on. Now let's say if I want to do this deleted end, so I'll put prev here, cur here. What I'll do is that I'll do prev dot next. Prev dot next is equal to root. So what will happen? This will now point to this, and this one will free it, so it becomes this. Yeah, so it's working. Okay, and deleted middle is the same. Okay, so this is the beginning, this is the end. Okay, I'm not writing it down so that you guys can study later on. Like this is exactly the code. This is circular linked list. Now let's say what's the problem with singular and circular linked list, right? You have to store a lot. See, you have to store two pointers to traverse. To go backwards, you need two pointers. You cannot go backwards. If you're at three, you cannot go at one like that. So here comes the use of doubly linked list. Okay, let's say this is doubly linked list. What doubly linked list does is that I have to make a doubly linked list first. Give me like 1 minute. Give me 1 minute. One. This is a doubly linked list. What does a doubly linked list do? Let's say I'll put some values 1, 2, 3, 4. So doubly linked list does what? It will have a left link and a right link. As in what? Let the left link here will be connected to, let's say, root, and the right link will be connected to the left link of this. This right link will be connected to the left link of this. This right link will be connected to the left link of this, and this will be connected to nothing. Wait, why can't I type? I'm just denoting null as x. Okay, this is the scenario of a doubly linked list. Okay, so how do I deal with doubly linked lists? How do I insert? See, now the thing is that you can easily move backwards with this. How? So let's say if I'm 3, if I do the left child, okay, I can move to this. The main thing is that this, if you see, this will be like this. Okay, I can move backwards. How? So let's say they are stored at 100, 200, 300, 400. So my first root value will be at 100, right? Now, obviously, if we remember, this one will point to 200 and this one will point to 100 so that I can go back. Now, this one will point to 300, this will point to 200. This will point to 400. This will point to 300. This is the scenario. So let's say if I am at 3, now wish to go to 100, right? So I can do what? Left child. So I'm left child is 2. So from 2 I can go 200. So 200 I went to this. And I'll go to left child and left child. Then I can go to this one. The reason I don't do Hindi, मैं हिंदी में पढ़ा सकता हूँ, कोई प्रॉब्लम नहीं है, लाइक हिंदी में इंग्लिश में वट एवर यू वांट, बट इंग्लिश थोड़ा सा लाइक हिंदी में लोगों को प्रॉब्लम हो सकता है, बट हिंदी लाइक इंग्लिश आई थिंक नाइन मोस्ट पीपल नो, क्योंकि तुम्हारे जो टेक्स्ट बुक्स रहते हैं तो हिंदी हिंदी में नहीं रहता ना, इंग्लिश में रहता है ना, तो मतलब लिंक लिस्ट जैसा टर्म वैसा चीज है, आई कैन टीच इन इंग्लिश सो दैट लाइक पीपल कैन, मतलब at least if you even don't understand when I am doing the, you can at least look at the diagram, get the मतलब इंग्लिश वर्ड्स जो बोल रहे हैं वो समझ के यू कैन अंडरस्टैंड स्टिल। हिंदी में बहुत लोगों को प्रॉब्लम हो सकता है कि हिंदी सबको उतना आता नहीं है। तो या सो ऐसे वी डिड लाइक दिस इज माय डबल लिंक लिस्ट। आई विल डिलीट दिस नाउ, ओके, नाउ आई विल वर्क विद दिस। हाउ कैन आई ऐड अ I'll copy paste this. Okay, I'll just add, let's say 7. Mm, no need of the addresses right now. How can I add the 7? Hello, hello. Let's say if we add it to the middle, first, it is very simple, nothing else. You have in this one, what do we have to store? Let's say, okay, let's say this is stored at 700. Okay. So on the right child, we have to store the address of 100. Okay. So this one will store 100, and this one will store root. And now this one will store 700. So what will happen? The connection becomes something like this, and this line gets connected to this. So we inserted in the beginning. Okay, like in earlier one, we were just working with one pointer. Here we are working with two pointers, the left and the right. That's why you have to like write two lines extra. Now let's say if we want to add at the end. Okay, so how can we work with that? Okay, let's say if we are adding at the end. So first we have to point this to this and this to null. So this will become what? 700. This will become what? 400. And this one will point to null. So this is how we can make at the end and the middle. Now let's try to do the middle. Okay. How can we do the middle? Middle one, let's say between 2 and 3. So first we have to point this to this. So what will we store here? Nothing but the address of the next one, that is 300. Okay. And on this one, then next we will store what? This address 200. Okay. So this is the scenario right now. Now we should be able to go back and forth. So 300 will now become what? 700. And 200 will also become 700. Now we have that back and forth thing. So this is how like we can insert, and this too will get deleted, of course. So this is how we can insert values into linked lists. Okay, doubly linked list. So let's try to delete now. Okay. Yeah, how do I delete this? Let's say the first element. Okay, the first element is easy to delete. How? We'll just point the root to this, and this will just be root. That's it, and we'll free this whole thing. That's it. No, just like the first one. And now how can we delete the end one? We will traverse till the end, and we'll just point this to null. Let's say this becomes null, then this whole link becomes deleted, as simple as that, and we'll free that one. Done. If we want to delete the middle one, so first we have to do what? We will connect this to this. How can we do this? We will now make this 100, right? So that is connected now. Now we have to make this 300. Then what will happen? We can go bidirectional. Done. So this thing, then free this thing, and now we got deletion from middle. So this we have covered insertion, deletion of circular, single and double. For your exams, you won't need more than this. This is enough. Okay. So what I have tried to explain without code is that how the thing works. This is what I interpret from linked list. This is how I understand linked list. This is a visualization of how linked lists work in totality. It's not like it will not help you write code. Now, if you can imagine this, no, you can write the code on your own. I didn't open any book or anything, and I'm not teaching you. I'm just doing it out of memory. How? Because I can see that, and I'm doing that. When I'm doing that, you should be able to implement the code. So the main logic, you should understand how to do it. Now, if you understand the logic, you should be able to convert it into code. That's what matters. Like, it should not happen ki the code, you know the logic, but you can't write the code. It's that simple. Showed you for the single linked list and the circular linked list how you can just with basic logic you can do that. Like, if you know the logic, you can write the code. Okay, then I'll just end the stream now. Chalo, bye bye.